My apologies for cutting that last video short, but we're going to go ahead and continue with where we left off. So I was just clarifying that if you need any help with the Keymaster clues and how to use that game board, just please come talk to me. It's really a collection process right now until you know and you've learned how to do what the game is asking you to do. So again, if you have questions, just come see me. All right, we're going to continue on. In part one of this video, we showed how to put those compound inequalities together and how to graph those. But sometimes that variable x, or whatever variable it might not be all by itself. So when we see this inequality, this and inequality, notice that we have x plus 5 in the middle of that inequality. If you were solving an equation such as x plus 5 equals 7, you know that in this equation you would subtract 5 from both sides. However, with compound inequalities, we think of this as having 3 sides. We think of it of having a side to the left of this inequality. Here we have another line here. So our goal is to get the variable x all by itself, and right now it's plus 5. So what we need to do is we need to subtract 5, but we're not saying that we're subtracting it from both sides. We're saying that we're subtracting it from all 3 sides, from that middle, from the right side of that inequality, and also on the left side of that inequality. So then when you're finished, that 5 cancels out. You're left with x. You bring down that inequality sign of less than here, and 9 minus 5 is 4. Over here, you subtract 5 from both sides. You bring down that inequality sign, and 2 minus 5 is negative 3. So now I can read this inequality as x is greater than negative 3 first. So what that tells me is I'm going to have an open circle at negative 3, and my arrow would be pointing to the right. My second half of this, if I look at the other side, is it's saying x is less than 4. So I'm going to have an open circle at 4. Numbers that are less than would be 3, 2. You can see how these two inequalities, those lines are going to run into each other. If we were going to place arrows, I would put an arrow here and here. But you can see that those arrows are going to run into each other, and since that's the case, you're just going to connect that line. So what this inequality tells us is x is greater than negative 3 and less than 4. So x can be anything in between there. Here's another example. Notice this example, we need to start off by adding 3 to all 3 sides. So add 3 here, add 3 in the middle, and add 3 to that negative 5. What that does is negative 5 plus 3 leaves me with negative 2. I bring down that inequality. I bring down that negative x. I bring down the next inequality, and 2 plus 3 is 5. Now, just like an equation, if I were to have negative x equals 5, I wouldn't want it to show negative x. I would want it to show x. So when I do that, to switch it, I can multiply everything in here by negative 1, which changes that x to a positive x and changes that 5 to a negative 5. Now remember, if you were solving with an inequality, you would have negative x is less than 5. You would have to multiply everything or divide everything by negative 1. And any time I multiply or divide by a negative, it flips my inequality. So my inequality shows less than, I have to flip it to greater than. That x, that negative x, is now just positive x, and that 5 is negative 5. So you can see how the inequality also flips. So keeping all of that in mind, when we're looking at this inequality, we have negative x. So we need to multiply everything, all 3 parts, by negative 1. So negative 2 times negative 1 is positive 2. Because I'm multiplying by a negative, I need to flip that inequality sign. That negative x turns into a positive x. This inequality also needs to flip and show greater than or equal to. And then that 5 becomes negative 5. Now I have it in place so I can graph. So x is less than or equal to 2. So I'm going to have a closed circle at positive 2. And my arrow would be anything less, so I would be pointing to the left. I would have a closed circle at negative 5. It's also including, and x would be greater, so my arrow would point to the right. So because those two arrows are going to run into each other, we get rid of the arrows and we connect the circles. What we need to make sure we do is remember that anytime you multiply or divide by a negative, the inequality sign flips. Here it flips both inequality signs. All right, another example, another AND example. We have x minus 8 in the middle, so we need to add 8 here, add 8 here, and add 8 here. That cancels that, leaves me with x in the middle. I did not multiply or divide by a negative, so my inequality stays the way it was. And negative 1 plus 8 is 7. Negative 14 plus 8 is negative 6. And I drop down that inequality. Now, I have an open circle at negative 6. X is bigger than or not equal, but x is bigger than negative 6, but less than 7. So that would connect and make aligned. You will start to begin to notice that all and inequalities connect. So my circles connect. I have no arrows. Now when we're looking at OR inequalities, we're going to still solve it just like we did an equation. However, this time, because it's not an AND, it has to be written as two separate inequalities. So to solve this first one, we're going to subtract 3 on both sides. That leaves me with 2x is less than 6. Divide both sides by 2. X is less than 3. I did not multiply or divide by a negative. My inequality stays the same. So x is less than 3. I would have an open circle at 3, arrow pointing to numbers that are smaller than 3. My second inequality, I would add 6 to both sides. That leaves me with 3x is greater than 18. Divide both sides by 3. And x is greater than 6. So open circle at 6, arrow covering numbers that are bigger. All OR statements, the arrows are going to point in opposite directions. All right, here's another example. We're not using the variable x, but it's still treated the same way. So we're going to subtract 1 on both sides. You're left with 3h is less than negative 6. Divide both sides by 3, and h is less than negative 2. Even though that 6 was negative, I'm dividing by a positive 3. So I keep my inequality pointing in the same direction. I do not flip it. The only time I flip it is if I'm multiplying or dividing by a negative. Here I'm dividing by positive 3. So h is less than negative 2. Open circle at negative 2, arrow to the left. With my other inequality in this OR statement, I'm going to add 5 to both sides. That leaves me with 2h is greater than 12. Divide both sides by 2. And h is greater than 6. So open circle at 6, arrow covers numbers that are larger than 6, such as 7, 8, and 9. I hope this makes sense, and if you have any questions while you're working through your homework, please don't hesitate to ask, and I will help you. Thank you, and good luck. Don't forget to search for those Keymaster clues. Please see me if you have any questions on those Keymaster clues. Thank you.